In this video, we want to solve for x given x raised to power 32 is equal to 2 raised to power x. Well, given x raised to power 32 is equal to 2 raised to power x. And we're required to find x. This is an exponential problem. And to begin, this power here is 32 and the power here is x. The base here is x, the base here is 2. Now we need to find a way to switch these powers such that all of the unknown variables are on the left while this value is on the right. What I'm going to do is to take the x root of both sides, which is the same thing as saying x root of x raised to power 32 is equal to the x root of 2 raised to power x. Now, when you have the nth root of a by law of indices, this simply means a raised to power 1 over n. So this simply means x raised to power 32 times 1 over x. And here, this simply means 2 raised to power x times 1 over x. Then this cancels this, and on the left we have x raised to power 32 over x is equal to 2. Since we already know that x root is the same thing as saying that base raised to power the reciprocal of x, then we can also do the same thing for 32 by simply multiplying this power 32 over x by 1 over 32. We'll do the same thing to the right. 2 here is same thing as saying 2 raised to power 1, then times 1 over 32. This cancels this. Then we have x raised to power 1 over x is equal to 2 raised to power 1 times 1 is 1 divided by 32. At this point, we have x raised to power 1 over x is equal to this power here, 1 over 32. I'm going to multiply both the numerator and the denominator by 2 and 2. So that this gives us x raised to power 1 over x equal to 2 raised to power 2 over 64, which we can also express as x raised to power 1 over x equal to 2 raised to power 2 raised to power 1 over 64. Or we say x raised to power 1 over x is equal to 2 raised to power 2 is 4, then raised to power 1 over 64. Let us multiply again by 2 divided by 2. Then x raised to power 1 over x will be 4 raised to power, this is 2 over 128. X raised to power 1 over x will be 4 raised to power 2 raised to power 1 over 128. So we have x raised to power 1 over x is equal to 4 raised to power 2 is 16 raised to power 1 over 128. Then we have x raised to power 1 over x is equal to 16 raised to power 1 divided by 128 times 2 divided by 2. Then x raised to power 1 over x is equal to 16 raised to power 2 divided by 128 times 2 is 256. Then we have x raised to power 1 over x is equal to 16 raised to power 2 raised to power 1 over 256. X raised to power 1 over x is equal to 16 raised to power 2 is 256. Then raised to power 1 over 256. Looking at the equation closely, we have x raised to power 1 over x is equal to 256 raised to power 1 over 256. We can then conclude that x is equal to 256. This is our final answer to this problem. And we can quickly do a verification check to confirm that that is correct. We were given x raised to power 32 is equals to 2 raised to power x. Now our x is 256. Then we do 256 raised to power 32 is equal to 2 raised to power 256. So to check if the left-hand side balances the right-hand side, let us work on 256 here. Two five six is equivalent to 2 raised to power 8. Therefore, this means that 2 raised to power 8 raised to power 32 should give us 2 raised to power 256. By law of indices, a raised to power m raised to power n will give us a raised to power m times n. Therefore, this becomes 2 raised to power 8 times 32. 8 times 2 is 16. 8 times 3 is 24. 24 plus 1 is 225. So we have 256. And then 2 raised to power 256 gives us 2 raised to power 256. And since the left-hand side is exactly equal to the right-hand side, that confirms that the value we got for x is perfectly correct. Thanks for watching. Please like and share, and remember to subscribe to my channel, and I'll see you in my next video. Bye.